So, the plot of the pH versus volume of the titrant added is called a pH titration curve. So, what would the manipulated variable, what should it be? Yeah, because that's what you're doing, that's what you're adding. And then you can read what the corresponding pH is, okay? So, yeah, volume of titrant, just make a note, that's manipulated variable. And then the pH responding variable. It's good to just practice that when you think about graphs and things like that, because even when we get into Chem 30 and Physics 30, we're going to do a lot of graphing. So now, all titration curves, when we look at them, they have an S-type shape to them. And there's a reason for that. When a strong monoprotic acid, so remember monoprotic means it has the opportunity to like donate one proton. Right? Mono meaning one and protic meaning proton. So if a strong monoprotic acid like HCl, say, is titrated with a strong monoprotic base, meaning that the base has only opportunity to accept one proton. The equivalence point, okay, right? So that the equivalence point is that point where the theoretical amount of acid and base is reacted. So our equivalence point will always have a pH of 7 because that's a neutralization reaction. The first point on the curve is always the pH of the sample. This is really important to remember, very important point. So when you think about your graph, think, okay, my pH of my sample should be first, okay? Because it's like putting the pH meter in your sample, and then as you add the base, it will change. Or as you add the titrant, I should say, it will change. So the pH changes very gradually at first. Think about it almost like how quickly the indicator changes. Like when we drop the base in yesterday, yeah, that's a good one. You drop it in, and the pink would go away really quickly. So it's like the pH didn't really change that much. But the closer we got to the equivalence point, it took longer. Okay, so this initial part where it's like the pH doesn't change very much, and it doesn't take very long for that indicator to not change color. That's the buffer region. Buffer. So not much is changing in the pH around the buffer region. As the endpoint is approached, the pH change will happen very rapidly. That's like, it's like one more drop and that's it, right? So that pH change happens within one drop. Okay, so it happens really quickly. And we'll be able to see that on the graph. The over-titration, so that's if that's adding the one extra drop so that it stays pink. That's endpoint, because endpoint is theoretically like one drop past the theoretical point, okay? And is asymptotic, so ASYMPTOTIC, to the pH of the titrant. Okay, so what does this look like? So if we had, say, a strong acid with a strong base, our volume of our titrant is our manipulated variable, okay? And our pH goes here. Now, if we think about a pH scale, so say this is like 0 to 7, 14, sorry. where should my pH be around? Well, you think to yourself, almost, and I would actually write this down. What is your sample? Is your sample the acid or the base? Read the title. It says a strong acid is titrated with a strong base. That diction indicates that the strong base is the titrant. Okay? It's like whatever you're titrating it with, that's like the titrant. So here we think, okay, so our titrant is a strong base, and the sample is the strong acid. So if the sample's a strong acid, it has a very low pH, and if the titrant is a strong base, it has a very high pH. So our pH is going to start really low, because like I said, think about it as we just keep measuring what's in the Erlenmeyer flask. We're measuring the pH in that Erlenmeyer flask. So what will end up happening, would be, say, like my initial pH. Say it's around 2, you know? It starts gradual. Okay, this is the buffer region. So the pH doesn't change very much, doesn't change very much, doesn't change very much. Whoa, like 2 drops and it skyrockets. Okay, so now see where it ends off at. Look, it's very, you know, we would say, okay, perhaps that's like about 13 or whatever, and this is like, say, 2. Okay, so very strong acid, and so very low pH, and I end up with a really strong base, giving me a high pH. Okay, so this is kind of a skill where I want you to be able to, if I just told you that's the only information I gave you, that you would be able to make a graph for me, just a sketch of kind of what the general shape would look like based on that. So let's try another one. Oh, and we can note here that this, so so here, let's label a couple things. This is the buffer region. Now, when this, like the sharp going up part of the graph here, okay, the middle of this, it looks almost like a line. It's going so, almost a vertical line. The middle of that line is the equivalence point, okay? So we would say this is like our equivalence or endpoint. And so we'd say the endpoint is at 7, pH of 7. So say we have a strong base titrated with a strong acid. So your volume of your titrant goes at the bottom, your pH on the side goes 0, 7, and 14. Think to yourself, what is the titrant and what is the sample? So the titrant is a strong acid. So that means I should end with a really low pH. And my sample is a strong base. So that means I need to start with a really high pH. So these ones, it starts really high. Okay. And it will look like so. So here's the buffer region. Very low, small amount of pH change there. Okay, so this is the buffer region. Then you look at that almost vertical line and pick halfway between it, and see we have our equivalence point there. Now again, it's a pH of 7 because we're dealing with a strong base and a strong acid. So our end point is a pH of 7. Okay. I just want to give you one more example before I do this. Yeah, maybe you have some space on your back or wherever you have. Because I want you to think about something different.